Hello everyone! For this activity, we are going to create a simple space shooter game, which you can move the spaceship left and right and shoot the enemies. Once all enemies are destroyed, you win the game. Looks pretty simple, right? If this is your first time creating a game, you'd be surprised how much detail is involved in the most simple games like this one. Well, Python has a great library called PyGame that will make this process easier for us. Well, feel free to follow along in your local environment if you'd like to, but I'll be doing this demo using the PopViz online IDE. The final code is already loaded for you, so you can run it and see the results. We'll look at the file structure first. So we've got the main.py, where we're going to add our code, and there are several images that you can choose from for the background, for enemies, and your player. So we will complete the game development in 9 steps. And step 1 is the basic settings. Here, we're going to accomplish 3 things. So 1, we're going to create a game window, which is 600 pixels by 400 pixels. Then we'll add a caption, then terminate the game when we close the window. So I'm going to tuck in the folder and wipe out the code that's already here. Import statements. So first thing we're going to import is the OS. Import OS. And this is used to locate the image files. Next, import PyGame. Make sure these 2 lines are at the top of your code. Then initialize the game. PyGame.init. This will give you a clean slate to start your program. Then let's create the game window, and the size is going to be 600 by 400, and we are going to store these values in variables so that later if we decide to change the window sizes, it's very easy to do. And we'll be working with these variables to put our player and enemies on the screen. So let's begin with width equals 600, height equals 400. Next, let's use the PyGame commands to create the screen. Screen, assign it PyGame.display.setMode. Inside it, add another pair of parentheses and put width, height. And you might wonder why there are 2 layers of parentheses surrounding width and height. And you can actually find out why from the PyGame documentation site. And you'll see that this function can take both width and height as one bundle and can take other optional parameters. Great, our screen is set. Now let's add a caption. PyGame.display.set_caption. I'll call this Space Shooter Game. Then here comes a very important part. The code is read from top to bottom unless there's a loop that will take you to the top and keep repeating a section of your code. And we need that loop in the game so that we can continue running the game logic until the game is over. In order to do that, we'll have to use a while loop, and we'll also need to be able to control the while loop. So let's create a variable called isPlaying and set it to true. And this variable will work like an on-off switch. And let's create that while loop. While isPlaying. Now that we can create that game window, we need a proper way to close it and end the program. So when the close button is clicked, we want to exit out of the while loop. And in order to detect if that close button is clicked, we'll need to know what events are happening. And this event detection has to happen over and over again. So we're going to insert that inside the while loop. So this is what we're going to do. For event in pygame.event.get, and this is going to retrieve all the events in the event queue, such as mouse clicks, key press, everything. And then we're going to use a for loop to go through each event and compare if the event type is equal to that close button. So we'll do that using a conditional statement. If event.type is equal to pygame.quit, and this is that close button. Let's exit out of the loop by setting isPlaying to false. So here's a quick recap of what's happening in that while loop. The for loop will grab each event in the pygame.event.getQueue, and if the event type is pygame.quit, isPlaying is set to false, and the while loop is done. And be careful, we have 4 lines with 3 levels of indentation. And let's see what this looks like. Run. Great, we have a 600 by 400 window with the caption showing Space Shooter Game. Let's close. Step 2. We are now going to add a background image. And background.png file is already prepared for you. And there are 2 other options that you can try out. And when we load up the background image to the screen, note that we have to point out where we want to place it in terms of its XY coordinates. And we'll be placing the background image at 0, 0, which is the top left corner of the screen. All right, let's code. So perhaps right underneath isPlaying equals true, we'll load up the background image. And we're going to assign it to a variable called background. Type pygame.image.load, and inside it we're going to use the OS library to join the directory and the file name together. So type os.path.join. We'll pass the directory first, os.path.directory name, __ file, __, and then let's put in the second parameter, comma, which is the file name, background.png. Now this will load up our file and then assign it to the variable background. And now that the background file is loaded, we need to put it on the screen. And where do you think that code should be? Hint, we can't just display the background one time and let it disappear. It has to be drawn over and over again. So we are going to place it inside the while loop. Let's type screen.blit. And blit means to draw. And we'll need to pass in 2 parameters, which the first is going to be our image background and the location of where we want to blit it, which is going to be 0, 0. And that is the top left corner of the screen. Next, this is going to be a very, very important line, which we're going to place it at the bottom of the while loop. And make sure it's indented properly. We're going to make sure that our images are updated every iteration of the while loop and show the most updated state. And that is done with this code. pygame.display.update. Now let's see if this works. If you have the previous window open, make sure to close it and let's run. Great, now we can see the background. If you'd like to try other backgrounds, change the file name to background2.png or 3.png. Step 3, we are going to add a player. And this will be done in a different way than what we've done with the background image. And we're going to do this by creating a player class. The player class is going to contain a constructor and variables and methods that we need to create the object out of. Once we have the player class, we'll create an object out of it like this. So your player object will use the player constructor to create itself, and we are going to pass 2 parameters, which are the width and height, or the XY coordinates of your player location. And the player is going to be located at width divided by 2 for the X, and the Y is going to be height minus 70. So if you're not familiar with classes and objects, this might be overwhelming, but don't worry, we'll be using this concept over and over again, so by the end of the project, you'll be familiar with it. All right, let's code. So I'm going to close out of the screen, and let's add the player class. Let's do that right above the while loop. Declare class, and then player with a big P. Inside it, we're going to create a special function called a constructor, which is called when an object is created. So def __ init __, and this is a reserved name used for the constructor that constructs the object. And let's pass in some parameters. We'll have to pass in self, which means this object, and then x and y, which will be the xy coordinates of where the player will be plotted. So self here is the instance of the object that's created. And this object will have its own x and y. And here we'll call it self.x, which is going to be assigned the value of x from the parameter, and self.y for the y coordinates will also grab the value from parameter y. Now our constructor will set the x and y coordinates for our player object. Next, we'll need a way to draw the object. So let's create a function for that. df, let's call it draw, and we'll also have to pass in self, so we can refer to the self x and self y. Then just like the background, we'll have to load up the player image and blit it on the screen. So let's create the player image variable, player image, and load up the image by typing in PyGame dot image dot load, and inside it we'll insert the file location, and we'll have to use the OS library to do that. We're going to use os.path.join to join the directory location and the file name. First parameter is the directory os.path.dirname __ file __, and then the second parameter is the file name, which is player.png. And note that there are two other player images that you can choose from. Next, let's draw it on the screen. So that is screen.blit, and pass in player image and the location. And we're not going to hard code the number of the coordinates. Instead, we are going to pass in self.x, self.y. And that is because our player object has to be able to move around the screen. So self.x and self.y will take care of that. All right, now that the class is done, let's create the player object. And here is how to create or instantiate the player object. Let's insert that line underneath the player class. We'll give the object a name of player, then call the player class with a big P, and pass in the XY coordinate of where you want to blit your object. So that is width divided by 2 for X, and for Y it is height minus 70. Great, so that creates a player object called player, and we'll plop it on the screen right over here. And the next thing we need to do is to draw it on the screen. And guess where we're going to put that code? Yep, that has to go inside the while loop. We'll have to draw the player over and over again. So let's place that right underneath the background, and we're going to say player draw. Let's run to see the results. Great, our player is now on the screen. Step 4, control the player. So in order to control the player, we'll need to be able to detect key press and have the player move accordingly. And there's a convenient PyGame function for detecting which key is pressed. So we'll use that, and we'll use the arrow keys to control the player object to move left or right. The player doesn't get to move up or down. This restriction makes the game more challenging. And also notice that the player doesn't get to leave the screen. Can you guess the logic behind it? So we're going to be using a conditional statement to add the boundaries for the player. All right, let's code. So I'm going to close out of the screen, and let's think about where we are going to insert that code. So we need to detect and respond to the key press continuously throughout the game. Hint, hint. Yep, we are going to place that code inside the while loop. So perhaps underneath player.draw, let's use a PyGame function to do this. So we'll create a variable called pressed, and this is going to store the state of all keyboard buttons. So type in pygame.key.get_pressed, and this will grab the state of all keyboard buttons. If a key is pressed, that key will return true. Then let's use a conditional statement to see if the left key or the right key has been pressed. If pressed for PyGame dot K on the bar left. So this is left key is pressed. If that returns true, then we're going to have to move our player towards the left. So that is going to be player dot X location. Let's do move 2 pixels to the left. Later on, if we think that 2 is too slow, we can up the velocity by giving this a bigger number. Next, let's detect if the right key is pressed. Next, if pressed PyGame dot K underbar right. If right key press is true, then move the player towards the right. So that is player dot X plus equals 2. Now that should work. Let's run. Right key, left key, looking good. All right. But look at this. I am lost in space now. This is not good. So let's go in and add the boundaries. I'm going to close out of the window. And let's add those boundaries by using a conditional statement. So only allow player to move towards the left if player.x location is greater than 20 pixels. And you can adjust this number to find what works for you. But considering that the player size is 32 by 32, 20 seems about right. Indent the next line. Player X will only move towards the left if player X location is greater than 20 pixels. We'll do the same for the right. If player.x is less than width minus perhaps 40-ish, considering the width of the player image, colon, and tuck in the next line. And now the boundaries are added. Let's test it out. Run, right key, and stuck. Left key, stuck. Let's move on to step 5. Step 5, adding enemies. So just like the player object, we're going to use an enemy class to create enemy objects. And we are going to spawn a whole army of them in a grid format. And we will be doing that using a nested for loop. So the outer for loop for x in range 1, 11 will create 10 columns, and the inner for loop for y in range 1, 4 will create 3 rows. Then we're going to use the x and y values to plot the enemies, and each enemy created will be added to the enemies list. And note that our enemies will be descending downwards. So close out of the previous window. Let's first create the enemy class. Let's copy the player class to create the enemy class. So copy that and paste it in. The class name will be class enemy with a big E. And it is also going to initialize itself by passing in self and the XY coordinates. And it will also draw itself, and we'll need to load up the enemy image instead of the player image. So swap player image with enemy image. And also change the file name from player.png to enemy.png. Next thing, we'll need to blit the enemy image. And we are almost done. There's one more thing that we have to do. So how do we make the enemy descend downwards? Hint, we'll need to add a line of code in the draw function. So every time we call this draw function, we are going to increment the self.y by 0.1. This seems like a very small number, but because the while loop will continuously call this draw function, it'll be somewhat faster than what you'd expect. But if you want to make the game more challenging, increase this number so that the enemies will descend faster. Next, so just like the player object, let's create an enemy object and draw it on the screen. So right below the player object, add enemy equals enemy with a big P, and then insert the location, width divided by 2, comma, perhaps 50 from the top. Next, we'll have to draw it. So underneath player.draw inside the while loop, put enemy.draw. And let's run. Great. our enemy is descending downwards. So the next thing we'll do is to spawn a whole bunch of them. So close out. Let's use a list to keep track of them. So delete the enemy instantiation here and replace it with the enemies list. So we'll put enemies bracket, and this is an empty list. Next thing we'll do is to spawn them in a grid format. And we'll do this with a nested for loop. So the outer for loop will be for x in range, and inside it, I'll put 1, 11, and 1, 11 will create a list with consecutive numbers starting from 1 to 10 inclusive. Next, the inner for loop is going to be for y in range, 1, 4, and this will create a list of numbers starting with 1, ending with 3 inclusive. And that gives us a 10 by 3 grid. Inside it, we're going to create enemies and append it to the enemies list. So enemies, append, and this is where we create the enemy object. Enemy, and the location is going to be x times 50, comma, y times 50. And you can adjust these numbers to control how far apart you want the enemies to be located. So I put 50-50 because each enemy width and height is actually 64 by 64. So if we put them 50 by 50 apart, then they're going to be overlapping. And that was intentional because I wanted them to look like a huge Lego block. Now that we've created a whole army of enemies in a grid formation, let's draw them. Remove enemy.draw and replace it with for enemy in enemies list enemy.draw. So this will go through the enemies list, grab each enemy, and then draw it on the screen. Great. Let's run. Looking good. Enemies are descending downwards. Step 6. Shoot lasers. So the player gets to shoot lasers by pressing on the space bar, and lasers are created from a class, just like the enemies, and they will be kept track of by creating a lasers list. So let's use the enemy class to create the laser class. So I'm going to copy the enemy class, paste it in, and change the values. So instead of class enemy, let's put class laser. And the laser will also need X and Y that we'll need to keep track of. And it'll also need a way to draw itself. For the laser, instead of loading up an image and splitting that on the screen, we're simply going to plug in a PyGame function that will draw a rectangle that looks like a laser beam. All right, so let's remove those two lines and replace that with PyGame.draw. It's going to be a rectangle, so RACT. And then inside it, we're going to pass in a couple things. So the first thing is, where do you want to draw it? We'll draw it on the screen. And we'll insert the color and RGB values. So this could be anything you want. For me, I already selected the color, which is 254, 71, 110. Then we'll insert the rectangle's location and the dimensions. So that is pygame.rect with a big R. And then inside it, we'll pass in self.x, self.y, comma, and then it's going to be 2 by 5. Great. The next thing we're going to have to do is make it go upwards instead of downwards, right? So let's alter the code. Self.y plus equals, change that to minus equals so that it goes upwards. And the lasers are going to move very fast. So let's put 2 there. Great. That completes the laser class. Now, just like the enemies, we'll have to create a lasers list to keep track of all the laser objects. So let's add that below the enemies. Lasers is an empty list. Next, let's draw it. And different from the enemy, it can't appear right from the start. The laser will appear when we press the space bar, which means that we'll have to detect an event and respond to it. And guess where we're going to place that code? Yes, that will be inside our while loop. And let's detect for that event. And we already have 4 events in PyGame event.get that we can use. So let's add our code underneath this for loop. If event type is, we're going to have to detect for 2 things, which is key down and key space. PyGame.keyDown, all caps, and event.key PyGame.k_space. So if the event type is both key down and key space, let's create that laser. And just like the enemy, when the laser is created, we're going to append it to the lasers list. So lasers.append, and let's create the laser object. Laser. Insert the location of where we're going to create it, and that laser has to shoot from the player. So we're going to put player.x, player.y. So the laser will be created from the top left corner of the player, and if you want the laser to be shooting from the center, adjust the player.x value. But for now, I'll skip that part. Let's draw the lasers. And let's put that code perhaps right underneath where we draw the enemies. For laser in lasers, laser.draw. Let's run and see if it works. Here we go. Here is my player. Left and right, spacebar, shooting lasers. Looking great. So that takes us to step 7. Step 7, detect collision. So is the laser overlapping with the enemy? When the laser hits the enemy and the laser should be removed from the screen. So in order to do so, we'll need to detect enemy laser collision. So here's a question to think about. So who is going to detect that collision? Is it the background? Is it the player? Is it the enemy? Or is it the laser? Well, the program would be most efficient if enemy is detecting the collision. So what the enemy is going to do is it's going to constantly detect if the laser falls within its area. In order to do that, we'll have to figure out the enemy's coordinates. The top left corner of the enemy is self.x, self.y. And considering that the width of the enemy is 64 pixels, the right corner coordinates are self.x plus 64, self.y. What about the bottom left? That should be self.x, self.y plus 64, because the height of the enemy is also 64. And the last corner should be self.x plus 64, self.y plus 64. So we can say that when laser.x, or the laser's x location, is between self.x and self.x plus 64, and laser.y falls between self.y and self.y plus 64, if both laser.x and laser.y fall in those ranges, then we can say that the collision has been detected. So let's create the detect collision function inside the enemy class. Right below the draw function, def detect collision, pass in self, so we can refer to the self x and y. Then we're going to loop through the lasers list and grab each laser and find out if that laser overlaps with the enemy. So for laser in lasers, so we have to create 4 conditions, right? If laser.x is greater than self.x and laser.x is less than self.x plus 64, and here comes the condition for the y. So I just did a line break because the condition was getting too long, and I'll need to indent it. Now let's take care of the y. Laser.y is greater than self.y and laser.y is less than self.y plus 64. If this condition is met, then we are going to remove the laser and the enemy from their respective lists. So lasers dot remove laser. And for enemies, same thing. Remove. And this time, we're removing the self. All right, now that the detect collision function is done, let's use it. And a good place to make that call is inside the while loop. And since we're going through the enemies list here, let's make the call here. So after the enemy is drawn, we are also going to detect for collision. So enemy.detect collision. And that should take care of it. All right, let's run and see if it works. Shooting lasers. And yes, detect collision is removing the enemy and the laser. Step 8. So how do you win the game? Or how do you lose the game? We'll need to insert those logic. And how about this? If the enemy reaches the bottom of the screen, then the player has lost. If there are no enemies left in the enemies list, then the player has won. So first, let's add the logic for how you can lose the game. So if the enemy.y reaches the bottom of the screen, then the game is over. And where would be a good location to place that code? How about right here where we're going through the enemies list? So after we draw the enemy, we're going to detect for collision, and then we're going to see where our enemy is located, and if it's located somewhere along the bottom edge, then the game is over. So let's put if enemy.y is greater than height minus, so for testing purposes, let's just insert 150. So when enemy.y reaches 150 pixels from the bottom, then we're going to print game over. Let's see if this works. And note that this print statement, it's not going to print on the game screen. It's going to print in the terminal window. So let's run. Let's wait until the enemy reaches height minus 150. And now pay attention to the terminal window. Yes, game is over. Let's close this. So the logic for losing the game works. Now let's add how you can win the game. So when enemies are cleared, or if the length of the enemies is less or equal to 0, then you win. And the location where we're going to place that is, let's check that for every while loop. So perhaps right above that last line in that while loop, let's insert the logic for how you can win the game. So if length of enemies is less or equal to 0, then let's print you win. Now, in order to check if this works or not, we'll have to actually beat the game. All right, let's run. There we go. Printing you win. Great. Close out. And that takes us to the final step of adding the endings. Step 9, add endings. So depending on the status of the game, let's show a different ending by simply displaying a corresponding text, you win or game over. And we'll do that by creating a display text function. And this function doesn't belong to any object, so let's place that right above the while loop. DEF for creating the function, display text, and we'll pass in the text to display. And first thing we'll do is we're going to need to create the font object. Let's give it a name, font. PyGame.font.system sysfont for system font. And then we're going to use the default and insert the size, which is going to be 50. Then we're going to have to set up how we're going to render that font. So let's give it a name, message, and font render. What are we rendering? We're rendering that text that we received as a parameter. And anti-aliasing. We're not doing anything fancy, so let's set that to false. And then set the color. Let's display a white text, so 255, 255, 255. That's RGB displayed in full. And then we're gonna have to blit that text. So screen.blit, and then show that message and designate the location. We'll say around 200, 160. So here is our display text function. We're going to use this function to show our endings. All right, so scroll down and let's replace all the print statements. So instead of print display text, we'll display game over. Instead of print, you win. Same thing, display text, you win. All right, let's test the game. Run. There we go. So this completes our space shooter game. And here are some further challenges to make your game even more fun to play. So display score is one that you might want to try. Next, this might be a little challenging. Make the background move downwards in a loop so it looks like the player is moving forward or upwards. And here's another challenge. Create a different type of enemy, and maybe this enemy appears in a random location.